Yep. It's been a while since I've done this, so you're going to have to excuse me. It has been a hot minute, has it not? Let me just get everything right like this. There we go. So, a hot minute indeed. Hi there. Is Rumko gonna be here? How am I supposed to know? Magic? I would guess he's busy. I'm really out of practice. Oh, I haven't been playing in... Well, has it been 10 days? Oh, I haven't been home for 10 days. How good it felt to not be home. I'm going to drink myself a coffee because, well, it's still the Blue Channel stream, it's the not. Yeah, exactly. So, how you doing? Can we have a stream where we all just play musical instruments? Yeah, and ideally different melodies. That would be perfect then. I have a topic actually for today's stream. I'm being serious. It would be really difficult to synchronize, and if it's not synchronized, it wouldn't sound great. I have a specific topic for today's stream actually, which is something that has been eluding me as of late. It's called pauli matrices. And first of all, how about... There you are, that's much better. Good boy. And second of all, I need to understand them. I need to understand understandable all. No, it isn't. It is not. You love the pauli matrices. Well, I'm still trying to get them. SU2 and SO3, I suppose, would be a good start. I think, for my purposes. So we have the special unitary group and 3D rotation group, which would also require a discussion of groups, I suppose now. And when the music streaming on Facebook, I know. I know. Okay, well, first groups, right? I dislike groups personally because it took me a really long time to understand them, which is groups are like more general rings, right? Is that what they are? Statements made up by the utterly deranged. So, a Lie group as well. My lord, why does it always have to go somewhere? Is a group that is also differentiable, a differentiable manifold. Brilliant. Wait, no, I know what the differential manifold is actually. No, that's not bad. Okay. Such that group multiplication taking emphasis about differentiable. Okay, good. Not really. Set of an operation. not. Ring is an algebraic structure consisting of a set with two binary operations, whereas group is a set with an operation that combines any two elements of a set to produce a third element. Isn't that just a generalization of a ring? Where ring requires a set with two binary operations. Ring requires a set of addition and multiplication, whereas group just requires a set of an operation. Rings are like groups of addition. Yeah. Rings are groups under addition and monoids under multiplication. The fuck is a monoid? I looked into it a couple of... Oh no way, like 2 weeks ago. Fields are groups under both. Are you guessing or are you stating as a fact? Because I can tell you at least one set with multiplication and addition that is not a field. Monoids are groups without inverses. Associative binary operation, identity element. Okay, so that's... I forgot that. So dumb. We're getting way off topic. The point is, as far as I'm aware, a group is a more generalized notion of a ring, and groups are what we were discussing when we were talking about, well, Lie groups, for example. Okay, splendid. Should we trust Reblax on this? I don't do algebra or combinatorics. Yeah, but this doesn't feel like... This doesn't honestly something... This doesn't feel like something that would be worth for Reblax's time, if I'm to be completely honest with you. These aren't really difficult things. Or at least they're not supposed to be. If they are difficult, that means I'm messing up. So I better not mess up. This is all my reasonable questions. Yeah, but I first prefer to look into soft stuff myself before wasting people's time. In order to ask the right question, you first need to know the answer, unfortunately. Which means that first I need to know the answer, and then I can ask the question. Okay. Groups define abstract concept by operation. Also, because transformation, the object sense, for instance, multiplication and taking the inverse of the division. Currently, the concept of addition and subtraction according to ideas of this continuous group where multiplying points are and their inverses is continuous. If the multiplication and taking of inverses are smooth as well, one obtains a Lie group. Okay, simple. That's honestly quite simple. If you can differentiate multiplication, that means you have a Lie group. That's too simple. I don't trust it. That feels too simple. What are we doing today? We're getting to pauli matrices, ideally. Hopefully. Oh, speaking of, I should be rendering in the background. What am I doing? Right, I forgot. How quickly I forget. Oh, I have very little space. That's not great. Okay, splendid. And just open the box as well. There are actually a lot of things I could work on now I think about it. Damn it! Blender, work with me here. So this is a different morphic, I mean. Also mapping onto a manifold and the inverse. You remind me of what it feels like talking to like a... Mathematicians are so horrible at speaking. Let me just say. Honestly, it's horrendous. And I don't think that's surprise either. I think mathematicians know this. Cheers, Remco. Hi. Like, how can you say so? As long as that's diffeomorphic, I mean, since it's also mapping onto the manifold. I understand what all of this means, but I really shouldn't have to. That's painful. We need another growth index to walk in. That's what we need. However, I am not a mathematician. It's really difficult for you to say the sentence like that and claim you're not a mathematician. It's been long since I saw a video. Yeah, Remco, it's been such a long... We should meet up soon, I think. I'm actually drinking some delicious coffee right now that I've been gifted. Okay. Believe it or not, Remco, I'm looking into pauli matrices. Good coffee. Yeah, the good coffee. There's oh my I promised myself when I was on the bus today that I would become less of a workaholic, and immediately I'm already getting crushed by all the things I need to do. Beautiful render animation. How were my mom's snackies? I haven't ate them all. I'm still chewing through them. But they are really good. I was surprised because all of them looked sweet, but the croissants were sour. Not sour, savory. There we go, savory is the word I was looking for. The croissants were savory. I detest coffee when I'm being not gonna lie, that's harsh. Work hard so you have more time for the make it chess department. Oh, it just reminded me I need to implement make it chess as well. I haven't even remembered that bit. Okay, so first things first, what I'm going to do is I'm going to make a post on YouTube asking people for help with the website, because that's needed. There are REE groups. I don't know what REE means. Unless that means really excited electrons. And even then I would be skeptical. It's just I don't know. What's that mean? Is that someone's name? You find like regroup this. What is that? Regroup is a type of regroup. You can't make this shit up. You can't make this shit up. Actually, I don't think that's true. This is hilarious. I cannot with mathematics sometimes. Tits and he introduced regroups of infinite dimensional calc-moody algebras. Oh. Ah. I cannot with mathematicians. I cannot with mathematicians sometimes. Because, okay, basically, he introduced regroups. He introduced regroups of a Lie type. Like, what are we? Oh no, yeah, and I brought Lycan in. That's what happens. That's how you summon, like. My bad, ADHD. I don't know if that's the right one. Tits and he introduced regroups, and in case you're wondering, regroups are a group of Lie type. We got sidetracked, didn't we? Right, I think I get what a Lie group is now. I hope. One would hope. One can dream. We can only hope. So now all we need to do is figure out SO3, SU2. The universe had tits and Lie groups and 7v1 I just imagine you being like violently pulled of whatever situation you were in. The earth just opening up. Math and tits is my two favorite things. Well, do I have some news for you? I need a cup. I really want to have a cup which says if it has tires or tits, I can make it squeal. And even funny, I took it from Lycan. Not Lycan, Skid. From Skid. Make it. Would you like me to send you a great video on this? On what? A great video on what? Group of all rotations about the origin of three-dimensional Euclidean space under the operation of composition, which combines two rotations by performing one after the other. That's like trivial. Alright, that's good. Which means special unitary group is only left. SO3, SU2 stuff. I don't watch videos on science because I'm worried that if I watch them I may plagiarize them. Lie group of... Oh! That's convenient. Wait! Hold on. Huh. Huh. Determinant 1 is all that's... Oh! Good! That's going to be a bitch to explain. I mean, it's understandable, but... Oh my lord, explaining it is going to be... Oh, no. It's good as in... Huh. Hi, Dekatsi.
Hello. How have you been?
Busy, tired. Mainly these two. SL2R is special, pun intended, for my thesis. I don't know what this combination of letters means. How do
I've been okay, I guess.
Glad to hear.
There's been a minor hiccup that mildly messed my day, but other than that...
What was the hiccup?
I found out that an order I've been waiting for like the past month has been cancelled because I didn't upload like one file that they were missing, and they have been sending me emails. I just haven't been seeing them. They were going to spam, so. That mildly sucks. It's just they're now refunded, so I gotta wait for the money, and if I get the money back, I'll see it. What happens next? It is mildly annoying, and it mildly messes up plans. But I guess I will fucking live, whatever.
Well, you live, you learn.
Yeah.
Good luck writing your thesis, Remco. About the goddamn time. Also about determinant string, obviously it needs to have magnitude 1. Every rotation can be rescaled to have magnitude 1 so it works out. Yeah, I know. The thing I'm thinking about is how to explain the concept of a determinant.
Make it.
Yep.
How was Birmingham?
Uh, it was weird. All of Britain was weird. They don't know how to design the roads. And they're also controlled by big traffic lights lobby. Because every single place with traffic lights had like at least every single pedestrian crossing had 3 traffic lights. They all were showing the same light. There was 3 of them. Because hold on, I need to draw a diagram for this because this has to be. I don't know what it's apparent. I think it's a custom in there because it was so comical because you'd have like a road going forward, then you have like a pedestrian crossing, and you'd have one set of one traffic light here, and then a pair of traffic lights here and here, and then you'd have like I don't know 3 of these crossings in a row, and each one of them would have the same triplet of traffic lights for some goddamn reason. The record was when we were entering a roundabout with Remco, and I shit you not, I counted, there were 9 traffic lights all showing the same exact light. They switched to green and it was like a brilliant light of Ra, just absolutely killing rivals.
I'm sorry, there were traffic lights on a fucking roundabout.
Yeah, there were traffic lights before.
What? Why?
It's honestly not the worst.
What's wrong with that?
I wouldn't even pick that as the worst roundabout in Britain. There was a point at which they.
Isn't the whole point of roundabouts so you don't have to have fucking traffic lights?
Well, there were certain also roundabouts where you just had like a circle drawn on the ground, like the road just became more rotund, and then in the middle you just have a drawn circle on the ground, and they called that a roundabout. It's a silly country. They shouldn't be trusted with roads. I don't know who gave it to them, but...
Yeah. I think you may be right.
CDH, that makes sense. Alright, so it's basically crisscross minus applesauce. Right. Let's figure this out.
I would ask more questions, but you went straight back to math, and I don't want to interrupt you again.
Well, what kinds of questions have we got?
Any good food? I mean, I know the answer is no, but I just asking just in case.
Yeah, Indian was really good.
The best food in Britain is that one that isn't British. Noted.
I mean, I don't mean to be a guy, but to quote Flame, the best British food is Indian. Which I mean, he wasn't wrong. But I also like Remco's version, which was the best Dutch food is Turkish. So I disagree with neither. Well, I mean, no, Dutch have good sweets. They just don't have anything other than sweets.
I mean, what can you say wrong about the kebabs, you know?
That's true.
Like, by that argument, best any food is Turkish, no?
How do you get the crown? Oh yeah, you haven't gotten the crown at all. YouTube is just scamming you. That sometimes happens.
Crown? What's the crown?
It's the thing on YouTube from experience.
Oh, the XP. I have no idea how they work. They make no fucking sense.
Yeah, I know. No, it sucks. Well,
like,
I'm not in control.
Sometimes I just type 3 messages and then I'm the crown for like half an hour. You know?
I have to say, this trip has been quite educational for me. And not even because as we were driving, Remco just gave me a lecture on special relativity that has really made me understand physics way more. Driving with Remco is such a delight. I love driving with Remco because he drives only as much as it's needed and not more. So you know how like every single thing in a car is an accelerator. The gas pedal, the brake, the clutch, the wheel, all of them are accelerators. They just accelerate you in different directions. So like when you're on a straight road and you're driving, that means you don't have to accelerate. So there is no point in touching any of them. And Remco understands that fact. And as such, driving with him is an absolute delight because
Remco not touching the wheel.
Well, he only touches the wheel when he needs to. It's phenomenal.
That sounds a little dangerous.
I will, I will say I really enjoy driving with Remco. I imagine most people would hate it because they would be scared shitless from the life. But I really enjoy driving with Remco. It's like a
I guess
roller
you don't
coaster
have-
ride.
Yeah, fair.
You never know. You never know. Sometimes
Most people would be scared shitless. However, Meki is already suicidal. He does not care.
I mean, it was more funny than anything. I have certain pictures of the driving capabilities, but I cannot show them on YouTube because I don't think I want them public.
You think it would be considered endangerment to show them on YouTube?
I don't want Remco to keep his license. I like driving with him.
Okay. If it's a license.
It is incredible to me how the more I learn about physics, the more of an appreciation for it I get, and the more I learn about mathematics, the more it vanishes. I just dislike it more and more the more I get into it.
True.
How do you find it genuine question, Lycan, how do you find this enjoyable? That's not me trying to be a hater, trying to reduce the topics you cover. No, I genuinely am curious. How do you find it enjoyable? Because with physics, you have a lot of annoying calculations you need to get through. But you always end up with a wild result, and that wild result is then proven to be correct. So, for example, special relativity, simplest case being that the fact that you have the boost, and what the boost tells you is that your t prime and x prime actually depend on, well, I don't think proportionality is the accurate one. The point is they depend on velocity. And that's mental because you have to get your calculations wrong then. Your calculations have to be wrong because how can your time and distance depend on velocity? But then you measure it and it turns out it's correct. Yeah, if you travel faster, you get time dilation length contraction. And that's really fun. But then you get into mathematics and you get a sentence like, where is it? Hold on. You get a sentence like, Tits defined regroups over finite fields of characteristics 2 and 3. Tits and he introduced regroups of infinite dimensional Kac-Moody algebras. And I just don't know. I feel it's a fun way. It's a fun and good way to kill time.
I mean, I guess if the tits are defined, you can make them squeal at least.
Glad for that reference.
Fascinating. All of you I need to look one thing right now. Look at Cathy Vocaloid. This is the best thing I've just seen.
No, yeah, I was looking at it in the maths channel.
Oh, it's in Math Channel too.
Yeah, like and sent it to my channel.
That
What can I
is
say?
fucking
What can I say?
brilliant.
I love tits. I feel like there are easier fields in science if you like tits. I don't know. I forgot what bird watching is called, but you should look into that. Genuinely, you're gonna love it, Lycan. There's so many great tits out there. I wonder if I am feeling lucky enough to look up great tit on YouTube. Because it's 50-50. I could get the result I'm looking for.
Well, on YouTube, I mean, it's a bit safer, I think. No?
Hold on, let me see. Great tits.
Like, you can get
Oh,
demonetized.
never mind.
because of fucking
There we go.
YouTube,
There we
right?
go. Got him. I did get the correct one.
No.
My goodness, those are some great tits.
What great hits, man.
Extract from ones, but abstraction is essentially the whole thing of math. I'm not questioning the validity of math. I'm questioning how is it enjoyable, or are they not questioning? Only I would like to know how it's enjoyable.
You should start a breeding program so you can breed some tits.
I remember I used to want to make a video about Leibniz formula for determinants. It had something to do with perturbation. Or permutation. Wait, was it not perturbation? Uh-oh. I thought it was perturbation, not permutation. That's a pickle. I'm less familiar with permutations. That's a problem. Blue-footed boogie, yeah. This is problematic. Am I getting distracted again? No, I'm not actually. Oh wait, no, I'm on point this time. But this finished rendering, which means I should probably tackle that first. There we go, beautiful. So for example, like, could you describe to me something you found interesting in mathematics? Let's go with that direction. So like, for now, just give me a keyword for something you found interesting. I mean, you could just go with Stokes. Make a company forgettable to me. You just said you're not a mathematician. You yourself said that. I mean, I still think you are a mathematician, but... Stokes or music isomorphisms. Let's go for music isomorphisms. Alright. So, you find music isomorphisms interesting. Elaborate on it. What do you find interesting in them? I mean, I'm not formally a mathematician, of course, I do a lot of maths. Yeah, that's why I consider you a mathematician. There are a lot of people out there who call themselves mathematicians, but they just are only interested in like very surface level mathematics. I don't want to gatekeep mathematics, by the way. It's just that I feel like it's very diminishing to a lot of people who study mathematics. That's kind of like, what would be a good analogy for it? You know, that's kind of like someone being interested in like healing herbs and such, and them calling themselves a doctor. Like we should have more layers for terms, I think.
Like
I like how they allow us to flip-flop between vector fields and covector fields. I like how they can be used to create inner products. I like how they generalize grad, div, and curl. And I like how they use such whimsical notation. Okay. Alright. Oh, I have actually a banger follow-up question, but I'm gonna leave that for later, because for now we're on this goose chase. So, they can be used to create inner products. I mean, the creation of inner product just follows from switching between vector fields and covector fields, I do believe. But they generalize gradient, div, I'm not certain what div is, and curl. Elaborate on that. How am I supposed to visualize that? That's a pickle. Oh, might not be. Oh, I have an idea. Oh, that's clever. some chance. For grad, we have grad is gradient, right? Yeah, nabla f, that is gradient. Yeah, it's nabla, so it has to be. And that's the sharp. Okay, so what does the sharp do? I'm gonna guess there's also flat. Music isomorphisms. Yeah, so what does the sharp do? Oh, that's also df sharp. Oh. I do understand, Lycan, by the way, that you have made a lot of graphs on the topic. You have to understand though that I don't understand anything from these graphs. Because once again, I don't know the basis. Pun intended, I suppose. I don't know how intended the pun is.
Pun intended.
df is partial dx plus blah blah blah. Hold on. The reason why that was the case, I remember the reason why that was the case is because there was an isomorphism between the derivatives and lines. I remember. Yes, I think so. I would need to write it out to actually. I would say that. I would say like in that I know it for a fact, but I don't understand it. Things like dx and dy and such are covectors. Okay, no, that part I can understand. Kind of. Or maybe I understand it, because the reason why I would understand it is because if there is an isomorphism between the derivatives and if there is an isomorphism between derivatives and covectors, then I can understand is not the right word here. I know. I know what that means. I have one question that could actually help me understand, you know? Which is something I find curious. Why is it only vector and... I'll explain it better later on my channel. I think you have already explained it better. The problem is that you're explaining it for mathematicians. I'm not a mathematician. Which means the quality of the explanation here won't really matter because, you know, a different target audience. My question that I've been a fair bit interested in is, what is so fundamental? I'll do a physicist explanation. You can try. What is so fundamental about vector spaces and covector spaces? So basically, we have a vector space, and that I understand. That I would understand on its own, very simple. But then we also have a covector space. The question of mine is, why do we only have like these two options? I don't know if you get what I mean. I get that one of them is a space of vectors, the other one is a space of maps, but there's clearly something more general at play here. There's something more underlying. A covector space is also a type of vector space. It conveys the same information as a vector space, but it's not a type of a vector space. And that's what confounds me. Covector space is a dual of the vector space. I know what it is. The question is like, why do we only have two? Could I give you a counterexample, and could I give you an example of why it confuses me, and then you can maybe understand? Do you know any potential alternatives? Well, I could give you an example of how I'm seeing it, and then you could understand what my confusion on the topic is. Because the way I see it, it's not gonna be a perfect analogy, because, well, unfortunately, obviously it can't be. But as far as I understand it, we have like vector bases, and then we have covector bases. I don't know the proper notation, so we're gonna go with what I just wrote down. Then what you do is this allows you to generalize the concept of tenses, right? You have, congratulations. You've achieved infinite. You've achieved infinite horrors of the universe you have just unleashed upon mankind. Great. My question is, what is the difference between this and this? Fundamentally at the core, we move on from vectors as a concept. Well, I don't know if we can pull it from vectors, but like for example, there is a difference when you get two vectors. Hide the figure. I'm thinking about how to explain my confusion with this, because my confusion basically is that like ex is very much not the same thing as this x, despite vector conveying the same information as a covector. Like a two-dimensional covector like 0, 1 conveys effectively the same information as 0, 1 because there is an isomorphism between the two. I'm hoping I'm using the word isomorphism correctly. But despite them conveying the same information, we treat them differently. And that's what eludes me. I understand the reasoning, the abstract reasoning for that difference. I understand the practical reasoning, which is that we consider these to be maps, we consider these to be the objects that we apply those maps onto. But that's like very concrete, and that makes it very confusing when you then start thinking of tensor products. Because with this kind of understanding, this doesn't make any goddamn sense. I mean, the dual of a dual space is just the original space. Okay, but why can't we have a trual? Why can't we have? So we take dual, which I don't remember the character for taking. It doesn't matter. We ball. So let's call it the ball operator. Ball operator, which is what you use when you ball. So let's say that the ball operator takes in your vector basis to a covector basis. It takes your covector basis to a trivector basis, because why not? And it takes your trivector basis to your vector basis. Like, why can't we have something like that? Why can't we have three? Why do we need two? The only way I can think is that they go in opposite directions. Elaborate on that, please. We'll appreciate. We view correct covectors differently. Yes, which is precisely why I'm asking. That's if we didn't view covectors differently, we wouldn't have a problem. The problem is that I don't understand them. Vectors end in a dot, so like v dot. Huh? You can map a field to a probably new vector space using vectors, while you instead can map a vector space to a field using vectors.
Meow.
Yep. Hi, Lucio. Hi. You can map a field to a vector space using vectors, while instead can map a vector space to a field using vectors. Right, that is true. That is true. You can have v to f with a covector, and you can have f to v with a vector. But, like that you say. I see them. Well, that's not bad. But what kind of ungodly horrors happened with a tensor product then? I'm a queen, okay, gotta go. Bye. Bye,
I barely know her.
Bye, Amoa. Bye, have a good one. See ya.
Ew. Bye.
So, for example, what happens? What happens if I have some kind of value like 5, right? And it's that value 5 is like a basis, second basis of a vector space, and like a first basis of a covector space. Like, what is this? What is this ungodly horror? Unless I'm forgetting how a tensor product works, because I also might be. That's also quite confusing. Tensor product. I swear, mathematicians are really not great at explaining things.
Yeah. Especially if you try to start learning something I do recommend grabbing books for that because they have specific uh, a specific target group in mind, as opposed to Wikipedia, which is just general, and mostly it's the most abstract stuff you can find over there. Which is technically it's correct, yes, but it really doesn't help you when you try to get
What if
the core of it.
what if you stop doing math and start doing math?
I've seen a lot of people take that path
Then
already.
then you are legally obliged to make a name change to pauli.
The problem is like
That
I
man
need to.
did consume a lot of caffeine and meth and like slept 4 hours a day.
The problem is I do need to understand this mathematics at some point or another. This is very much required. Even right now, I'm trying to tie in the quantum mechanics to NMR, and abstract mathematics is the only thing in my way.
Which part of abstract mathematics?
There are a lot of fields actually.
Okay.
The abstract part.
A lot. I mean, I have quaternions pretty much nailed down. I have algebras of, well, depends on what kind of algebra, I suppose. From matrices, that one is fine. The block sphere, well, block sphere isn't abstract. That one is more physical, so that one I have got covered.
Yeah.
Kind of groups, or rather linear algebra, I would say.
All the terms and stuff, they do ring bells from stuff I studied like 3 years ago. But for example, with vectors and covectors, I do know how they behave and the general vibe of it, but for the finicky details, I'm so out of the loop for it.
At what level of education have you like stopped going further?
I'm like halfway through the bachelor.
Have you gotten to
for
tensors?
Mathematics and chemistry.
Have you gotten to tensors?
Yes, a little bit.
How big of a
But I
little bit?
do not remember a lot of them.
Because that's the problem. Because normally vectors and covectors are trivial because they have a very obvious, I would say, interpretation. The problem is that the abstract interpretation is a lot more tricky generalization.
It's obvious in the sense of getting the general gist of it, yes.
No, the specific.
Going into the
the specific covectors.
No,
the specific covectors are maps, vectors are vectors. The problem is that once you get into more general, once you get more and more general, you have bases.
Still easily trip. But yeah.
No, because when you get more general, the only problem is that you start mixing bases of maps and vectors, and that doesn't make any sense. Because what do you mean to have a basis of a map makes a basis of an object the map is applied on? Making a function will just take a covector input for every vector and a vector input for every covector, then they'll dot with the respective covectors and then multiply. Once again, Red, are you guessing or are you stating a fact? Because earlier on you gave me a lot of little stuff comments at the end of which you said you don't know. You really need to get better at stating that part in advance because it's important. It's really, really, really important. What do I do this? Let's keep the yellow and let's keep the yellow. Actually, we'd like them both to be equal. which means that this, there we go, and right here add pi by 2. No. Subtract. Got it. Okay, brilliant. And then what we want is we want a copy of this entire thing. Or rather, there we go, and then there we go, this. Subtract 1/4, so 30. Uh-oh. Wait, no, that's incorrect. What, where are you? Oh, that's why, I see. Oh, that's a problem. That's a big problem. Well, not that big of a problem, I just need to do some maths. Two. Beautiful. And then right here, combine X, Y, Z. Splendid. You make me doubt myself. Yeah, that's good. That's good. You should doubt yourself. It's science. That's a big part of it.
It sounds so rude, but yeah, kind of.
It's offset in the wrong way. Huh. That's a weird constant. I could crunch out why I exactly need this. I imagine 90 degrees rotation here. We're not using that anymore. Somewhere here must be a reason why I need to offset in such a weird way, but well, it doesn't really matter at the end of the day. There we go. I see now. That makes sense. Okay. This is more correct. That's still incorrect. Right, I'm an idiot. That shouldn't be there. Pi by 2. That's still incorrect. I'll think about it in a second. I'm back. Okay, that's good. Need me to explain vector and covector stuff? Well, yeah, I would like to have a better intuition for what is a covector to a vector. I have a new girl I'm interested in. Oh, I haven't had the time to read it. I'm really sorry. I can read it right now, actually. Give me a second. Well, I'm curious to hear the updates in the future then. I'm curious to hear on the updates in the future. I'm gonna have my fingers crossed for you. Right. Now the question is, why doesn't this work? Piss off. I said piss off. There we go. Staking that value. Ah, because we're subtracting in the wrong place. Well, no wonder. The only problem is it's going backwards again. No idea why, but I'm not gonna question at this point. This is correct. The only problem is that right here we're getting the X, which means we don't want it offset this way. Because also Y, which means we want to subtract pi. Never mind, pi by 2 was correct. The only problem is that that position is incorrect. Oh. That's good, that's correct actually. There we go. The whole point to show here is that rotation at an offset gives the same value as the rotation, and also rotation at an offset taken from the other coordinates also gives the same value. The point we're trying to show. Which means that what we like is curve. Curve line, there we go. And we want, oh, we could calculate this position actually. Yes, we can. Beautiful. All right. So all we need to know is the right height and the right width. That will give us everything. So first of all, let's make the radius smaller. Second of all, let's move them side to side. Actually, this is supposed to be on the y coordinates. This is supposed to be on the x coordinates, like so. Then we're going to have the starting and ending point the same for now. And what do we need? We need the curves to start at the tips of the arrows, which means that right here we have the arrows. This gives us the height of the arrow. We want it to start at the tip of the arrow, which means that the red arrow, we want its x coordinate to be this. No, I said this is what I meant. And this one's y coordinate to be this. And then vector math, we want to add right here this and this. And then we need to isolate the specific. This is tricky. For red arrow, we want to isolate the y. For yellow arrow, we want to isolate the x. Like this. And then into these two values, we plug in whatever we want the offset to be. The height is wrong as well. I'm going to guess it's wrong because these are doubled. They are doubled. Look at me. I know my animations so well. This is doubled, and then this also has to be doubled. Beautiful. Which means now into these two inputs we'd like to plug in the length of our things, which we can get from the sine and cosine, if I am not mistaken. Let's see. Sine is for the red, which means yellow has to be sine. Almost. That's incorrect. Or it could be correct if once again we just multiply by 2. And right here by minus 2, obviously. A couple of problems. Couple of problems. Okay. Oh, it's fine. Let's tackle it one at a time. First of all, first issue is that we're having this after the absolute, which is just incorrect. This should be right here,
Uh-huh.
and this should be. There we go. This is also after the absolute, shouldn't be after the absolute. That's the first issue. Yeah, they're wrong way, but they're at least. There we go, now they're correct. That's exact. Now the problem is in their heights. That is, for the yellow arrow for the yellow ball. Yellow one is this one. Good. You can see it has the correct height. It's not the correct length. In fact, the length is an inverse of what it should be. At 0 it should be maximum, at maximum it should be 0. And everyone knows that when we're dealing with trigonometric functions, obviously that means you have used the wrong one. So if cosine uses sine, so sine uses cosine, which means that its length, whilst right now being a sine, should in fact be a cosine. Okay, that is not promising. That is very much not promising. Oh, it's because it's offset. Right. My lord. Which means right here we need cosine. Beautiful. And then offset sine.
Mm-hmm.
Look at that. Professional. Good. Mickey, would you like me to
Every time
continue
I
to talk
see-
about the musical isomorphisms? Honestly, I wouldn't mind that. I mean, if it really is the generalization of every single operation on, if it really is the generalization of every single operation on vectors, that could mean, okay, so hear me out, like, first of all, hi, Holy Finger with hi. First of all, hear me out, because soon-ish, I would also like to add in Maxwell's equations to the roster. And I will say, if you actually manage to explain musical isomorphisms to me in a way where I actually do find the same beauty in them that you do, I think it would be hilarious to explain the entire concept of electromagnetism using Maxwell's equations, but have all of these equations expressed in terms of musical isomorphisms. Because that would just be funny. So I can tell you that much. If you explain it to me properly enough, I am willing and tempted to do such a thing. I'm just basically as much as a give as I can give. That'd be amazing. Yeah, I know. And just this and this. And just. There we go. Beautiful. Okay, so gradient started playing. Yeah, go on with the gradient. What's that? Vainly is both Jimmy Page. Unbelievable. Katsu must be smoking something. So we have df, right? Right, so df is isomorphic to a vector. Oh, sorry, covector. Wouldn't that also make it isomorphic to a vector? Or am I getting ahead of myself? df is equal partial fx dx fy dy. Okay, so basically, because once again, I need to understand it properly, so my apologies, like, and I need to go through this slowly then. Let's just consider a two-dimensional case. I hope dimension is generalized. In which case it would be just df is equal to partial. I could actually give this a page in my drunk science notebook if you want. That would be quite an honor. All of special relativity that I know has only 2 pages in there. There's actually a lot more special relativity than you would think. It's cramped. dy. Okay, so in this scenario we have. Let's consider it separately. So the way I'm understanding is this right here would be df, and we're saying that it's chain rule on two separate sides. So basically we have the magnitude. If we consider it only on the x, then we have the magnitude of how much df is changing in relation to change in dx. And if we consider on the y exclusively, we have how much df is changing, how much df is changing in relation to dy. So on their own, they would be kind of like this. I'm picturing it wildly, but sure. I think I get it. I think so. I think I get it. I'm decently certain. Oh no, because I'll be higher. This will be inverted. Because it will be normalized differently. Also, I'm pretty certain these two would be marginally the same. Which means only partial matters, and it's just partial in each way. I think I get it. Holy shit. Hold on. Wait, whoa. Whoa. Wait, because this could be incredible. I don't know if I'm seeing it right, but like, hold on. Please, I am so hoping I've got it. Because that would... if this is correct... The plus left. If this is correct, then I think I get it. I do understand that most of my thought process happened in my head. I understand. But, Lycan, am I correct in the vibing that this is the case? I could explain what I wrote down, but I feel like if I'm correct, then I don't need to explain. Am I understanding this correctly? Oh, the silence is killing me. The tension. I also do have a whole playlist just for studying physics I got from Remco, so... which is 48 hours long, which I suppose could be enough for this explanation. In the meantime, as you're answering, Wayne, okay, you're getting very close. Oh, because then I see it. Then I see what you mean then with dx dy being bases. The roughly there is really close. Yeah. Because then I guess I get what you mean. I finally do actually see it. Like, I knew about it from the last time you explained it to me, because I knew for a fact that there was an isomorphism between the two, but now I like clearly see the connection between the two. Or I guess, hold on, I guess this. I don't know why the covector, but trust. There is a very good explanation for why that's the case. It's non-rigorous though. But it shows it really cleanly. Okay, I'm with you. I'm with you with the F. Okay, you put the squiggles there. That's correct. Oh, I will be honest with you. I don't know. I don't know why the squiggles are meant to be there. I mean, I know what they mean, like covector, right? I don't know why it has to be a covector, not a vector. For a covector is superscript and no squiggle, but still. You know what? I actually prefer superscript then. Superscript is actually better notation. It's clearer. It screws a bit with, or it might actually not. Wait, no, it. Oh, it doesn't. That's funny. Are you familiar, with, are you familiar with Einstein notation for sums and summations? Because then I would be curious if that's the reason for why we have we have subscript and sub. Yes. Oh, there we go. It feels incredible to me that I actually it feels like, oh, what was the movie? I forgot the movie. Or not even movie, it feels like We Happy Few, when you just stop taking the happy pills and all of a sudden you just see reality. Like the entire time, like, and I saw you talking just absolute gibberish. Or a better one, Fablehaven. To all the 3 people on the planet in my audience who are familiar with Fablehaven, in Fablehaven they drink a special kind of milk that allows them to see magical creatures, and that's basically what I feel like right now. It's so funny because as well, like you, I just noted it down and all of a sudden, and I finally realized why that's the case. Like genuinely, this is why this right here is all I needed to do in order to figure out why that's the case. That's hilarious. Okay, but yeah, I'm with you, Lycan. DF is a covector. It's math on the screen, yeah. And you better be paying attention. It might appear in videos in a couple of months. Unfortunately, my schedule for now is a bit taken with the videos, so we'll be pushed further down the road. There we go. Okay, make it. This is a very relevant question. Do you want to stick to Euclidean metric here or generalize to any metric? Obviously generalize to any metric. Duh. Ideally. Also, who uses the Euclidean metric? Come on. Kids are hip nowadays. They curve spacetime. Oh wait, sorry. No, we're doing mathematics. I forgot. You don't have time. Okay. There we go.
I'm looking up random math bits in completely different topics, but reading up on for example, ill-conditioned matrices, which is for essentially you assign a value to a matrix, which kind of corresponds to its computability, and if it's too large, it's deemed as ill-conditioned.
Yeah, wait till you hear about the good quantum numbers.
Yeah. Sometimes you need to make up a metric to get a feel for it.
Working on another math since math exam is next week. Well, good luck. Good luck for you, Holy Fingerbowl. You'll be able to do it, I believe so.
Also amazing when a random brutal German term pops up, and it's not eigenvector. It's Austrian in homological algebra.
Uh-oh. Uh-oh. Oh, okay, I'm back. Never mind. Mind was dying briefly. df sharp equals df by dx dx sharp plus df. Can I write it in more general form? I hope you don't mind, because it feels easier. There we go. How would you particularly denote an entry of an inverse metric tensor? Hold on, let me first make sure I have this correctly. Dx sharp, right. Hold on, I need to decipher your message first. I feel like that clip of Gandalf going through Eldritch Scrolls. So make it, how would you in particular, denote an entry of the inverse metric tensor? If I recall correctly, when you have a metric tensor, I don't know, AB, when you say inverse metric, do you mean this? What kind of inverse are we talking about? Because not gonna lie, I am feeling very... Okay, not gonna lie to you, I am feeling very light on my skills of operating with Einstein's sum notation. I understand it, I know the rules, but what you have to consider is that I have no experience
And
with
so
doing
do I.
that.
No, I don't.
Yeah, like I appreciate the reference. What you have to understand, like, is that I have no experience working with it whatsoever. So that's gonna be... Hold on, let me think. I recall it was the same as... Well, I remember how it worked with the Minkowski basis. We basically switched from double... Was it covectors? It was either switching from this to this or the other way. I don't remember which way it's going. Also, that's the wrong character. Sorry, I've also been looking into quantum computing as of late, and over there they screw with me by having a symbol that's very similar to tensor products. I don't remember which way it goes. Dx is a covector, technically it should have the I in the superscript. Fair point. There we go. Sharp tends covectors to vectors. That makes sense. But that's flat. I'm going to make a wild guess about what flat does then, if you don't mind. Do you have this kind of character when it comes to musical isomorphisms? I think that was the character. I haven't read music in a while. I'm pretty certain that was the character. Okay, so dxi sharp is in general going to be metric up on E. Like this. Right, so sharp tends covectors to vectors. Jeez, your base is vector. Oh right, lower it has to be down because base is vector. Technically, if you want to be really fancy, you could note you could do the whole vectors are derivatives thing and denote it as partial xb. Oh, that would be your bases. That makes sense. Okay, so sharp turns your covector into vector. The sharp turns your covector into a vector. Flat, I would finally guess, turns your vector into a covector. You should try putting your graphs on Wikipedia, by the way. I feel like they very much should be there.
Also entirely possible that there is no equivalent for double sharp and double flat in that mathematical structure.
Covector space and Ktor and then you
Yeah,
have
technically it would be what happens if you flat a function that also that already does the flat. What would pop out at the end?
yeah, we would have a covector space. Person. Keep an eye out in Discord. Alright, we'll check in a second. Fire. Right. Gradient is. Ah. Okay. So that's curl. That's oh my. So it's you're taking a path through them. Oh wait, so do you have like corresponding spaces for each operator? No, that can't be it. That cannot be it. I refuse to believe that is it.
It's the dual thing again.
It's what?
It's the dual thing again.
Hmm. You have, okay, I see. You have different space corresponding to each operation. For the gradient, for the, I forgot what the div is, it can be deviation, that would be, and then I don't remember what div is, and the curl. I'm doing it. Oh, the way of sticking of vectors, because vectors restrict us to lower dimensions and flatter spaces unless we use shit like Levi-Cita connection. I see. Oh, wait, so this is generalized notion because you don't have to apply it on vectors. Hold on, though, I need to mull over this, that's tricky. I have a question. Is there an equivalent of this that would be a vector instead of a covector? Oh, the answer probably was yes, so that's good. Because the only problem is that this is the only thing that's screwing with me. Because the only thing I'm missing then is, because in that scenario I understand what this basis is. Like that basis right there is basically a combination of these two things. That's your basis. But that's the basis for covector spaces. Is there a basis for? Is there a similarly usable analogy for bases for vector spaces? It's honestly not quite as headache inducing as I thought it would be. It's surprisingly understandable. Okay, so then we have f is equal to sum f x j e j j. Which means that we have the f equal flat df. Or do you? There we go. It reconnected. It reconnected. Stream being window mine. That's not on your end. Like, don't worry. Don't. Damn it! I just realized I can. Wait, should the E be? No, it should be. That's true. It should be. Oh fuck. Yeah, because then you have a given metric. Now this is headache inducing because basically this goes together and then you have a given index, which means that you get your basis by having a metric onto infinitesimal. Doesn't this inherently depend on the isn't it a bit circular? Oh no, because it's based on your metric. I see. Oh, Lord, that's horrendous. Oh, maybe it's not. Your vector basis. So your vector base is then flat. Because that gives you your covector. Oh! It clicked, I think. Wait a second. Wait, hold on a second. Would it mean then, unless we already know it down, I just didn't know this. Oh, I think we did. Would it then mean that EJ sharp is equal to inverted? Would it mean that? Yes, okay, that's good. Well, to be fair, that was JSJ? No, JS. DXK is kind of weird. Oh, okay. I think I get it now. Partial dxk. Right, because you only have your bases in the vector space regardless, which means why would you have it in? And that depends your metric. X just not dx, just x. Oh, just x. Right, just x, that's true. That's true, just x. This is slightly headache inducing now. That's why, then this is why. Okay, no, I think I get it. Oh, that's actually quite clever. That is quite clever. If I understand it correctly. I'm still not certain if I understand it correctly. If I understand it correctly, then I do believe it is quite clever. If I don't understand it correctly, then it's irrelevant what I say because I don't understand it correctly. You're basically thinking of your vector basis, right? Sharp of your vector basis as just the infinitesimal in a given direction. Well, the metric, but you know, who cares about the metric? We're gonna leave metric as an implied identity for now because it makes it easier for me to think. You're thinking of your vector bases as infinitesimals in a given direction, whilst you think of your covector bases as the change in relation to that direction. I think. I am the fool. Also want to know something cool, go for it. And I'm out of my nice coffee. As you're writing Lycan, if you don't mind, I hope, I'm going to be... Covectors on tangent spaces on manifolds describe infinitesimal lengths, which means that you can still think of the notion of dx as an infinitesimal and a covector. Wait, dx is a covector?
Yeah.
Oh right, I've got them backwards. Vector bases are changes in relation, whilst covectors are the infinitesimals. That makes sense.
That's fun.
Single vector notion of dx infinitesimal and the covector. That makes sense. That makes sense. That's a nice isomorphism we got there. I have to say, this was the breakthrough right here at the top. This is what got me to understand it. Funny enough, this is genuinely I just you didn't hear it, but in my head I had the quantum mechanics from Oppenheimer music playing in my head. The Hodge star operator, the Hodge star duel. Yeah, sure, go for it. You know, while we're here, keep up the momentum. How much do you know about the wedge product? Not much. Very much not much. And nothing would be an accurate description, actually. We can leave it for another time, Lycan, as well. It's not gonna lie, I'm feeling a bit tuckered out. It's been a lot of thinking this stream. And I haven't even gotten to the fucking thing I was supposed to be researching. Ah, right. It's fine. Remco gave me a really nice source for it, so I can do it off stream. Another time is better. Okay, this is a really good start though, because this I understand, this right here. And also, Lycan, you should, I think you should be very appreciative of physics, because the sole reason, like the beginning part, that one I get, but the sole reason why I'm able to understand this is thanks to a special relativity lecture from Remco. So you have Remco to thank. Wedge between V and W is V tensor product W minus V tensor product W. Okay, so it's like a generalized cross. If I'm understanding correctly. At least it looks like a generalized cross. Yeah, okay, that makes sense. So a cross is a type of... So cross is a subset of wedge product for when the V and W's we're talking about are exclusively vectors? Is that how tensor products work? I would need to also read more into tensor products as well. The Hodge star list the cross to the wedge. Oh, I see. Huh. Well, anyhow, regardless and as such, I think I'm gonna go for now because I'm exhausted. I have only came home today and I immediately got into work, so that's such is life. And for now,
Have a snack.
that'll be it.
Get fresh.
Well, don't tell me what to do.
Bye.
And for now, that'll be it. Thank you so much for watching and have a great day.